So when we talk about routing protocols, we got RIP, Routing Information Protocol, OSPF, Open Shortest Path First, ISIS, Intermediate System to Intermediate System, BGP, Border Gateway Protocol, and then EIGRP, Enhanced Interior Gateway Routing Protocol. We learned in the previous class that all these protocols are good in its own place. So we had to understand the characteristics of each protocol so that we can use them in the right place. As the first protocol, we learned RIP, Routing Information Protocol. We might have learned even in CCNA level RIP, which is the distance vector protocol. It has two versions. Version 1 is class full. Version 2 is classless. We don't really have class full networks in today's environment. We have subnetted networks. So definitely we need to have version 2 in our routers. Some new devices, by default they come with RIP version 2. But most of the devices in enterprises, the default version is going to be version 1. We put version 2 and enable version 2. The big difference between these two is no broadcast in version 2. Instead, we use a multicast address 224.0.0.9. So instead of sending broadcast, we send only multicast. So multicasting is good. Right, multicasting is good. About multicasting we'll be learning. If we have not started that topic, we will start later after the routing protocol. You will see how multicasting is many times better than unicast and broadcast when it comes to talking to a group. See, if you want to talk to everyone, then broadcast is okay. Unicast is bad because you want to talk to everyone. If you want to talk to everyone, broadcast is the good one. Broadcast address will take the traffic to everyone, so you send a copy of your message to the broadcast address. But if you do unicast instead of broadcast, then you need to duplicate the packet as many times as the receivers are. If I have 100 computers receive the packet, then 100 destination unicast address. So 100 times I need to duplicate the packet. Multicast is the best option for interacting with a group, to interact with a group, to talk to a group. Multicast. So, multicasting is used by every routing protocol in order to talk each other between the routers that runs the same protocol, and also sometimes to share the updates. The multicast address is used, sometimes unicast, sometimes multicast, it depends. But doing broadcast is bad, so except version 1 RIP, all the other protocols do multicast. BGP does unicast because BGP is TCP based. application layer protocol. RIP only uses the broadcast address to send the update. Version 1 RIP, not version 2. Version 2 uses multicast address 224.0.0.9. There's no big difference between version 1 and version 2 except that classless and classful. RIP version 2 is classless, version 1 is classful. The other difference we just learned, the multicast address 224.0.0.9 for version 2 and 255.255.255. The broadcast address is for version 1. Yeah. So we all know how to enable RIP and so on. RIP has got some timers, like every 30 seconds periodic update will be sent. What does that mean, periodic update? Whether there is change or not, the updates will be sent, means the entire routing table will be sent every 30 seconds. That is periodic update. Periodic. Same interval of time. That's what periodic. Every 30 seconds. When a router don't hear from a adjacent router for 180 seconds, the routes will be removed. The route will be marked for removal, and which will get removed after 240 seconds. So whole time to decide whether the routes are possibly down is 180 seconds. And the removal of route is after 240 seconds, which is called flush interval. The metric of RIP is hop counts, as we saw earlier in the previous class. The loop is prevented by using the hop count limit, which is 15 hops. RIP can support only 15 hops. So if there is a loop, it won't go more than 15 hops. Metric 16 is unreachable metric. There is also another default feature of the router called split horizon that is involved in preventing loop. Split horizon rule says route learned from a port should not be advertised back on the same port. Alright, so RIP is also dealing with some other topics, like we have some other topics in RIP like route poisoning and poison reverse. See, when routes are coming every 30 seconds, the updates also come. If updates stops coming for 180 seconds, after 180 seconds, the router immediately puts the metric as 16 to inform the other downstream routers that the route is no more. Why it puts 16? 16 is an infinite metric, unreachable metric. We call this as route poisoning. Poison reverses going back to the source by overriding the split horizon rules to reconfirm whether the network is really down. It reconfirms by sending 16 hop metric. This all happens in 60 seconds after 180 and before 240. So between 180 seconds and 240 seconds, this route poisoning and poison reverse happens. At last, at 2/40th second, the routes gets removed from the routing table. So this is all the story about RIP. One more story is left, that is called summarization. RIP supports auto-summarization. If you want to have detailed routes in version 2, you may say no auto-summary. Yep, this is about RIP. If you have any question about RIP before we get into EIGRP, you may ask now.
Sir, one more time, sir. Poison reverse, that concept.
Okay, see. Route poisoning and poison reverse are same, but the direction is different. If you say we have router 1, router 2, router 3. Now, there is a network called 1.1.1.1 which is advertised by router 1 as what? 1 hop. Router 2 advertises it as what? 2 hop. So according to router 3, 1.1.1.1 is how many hops? 2 hops. According to router 1, 1.1.1.1 is 1 hop. According to router 2, it is 1 hop. According to router 1, 1.1.1.1 is directly connected. It is 0 hop. Yeah. So what happens is, as soon as this network goes down, router 1 will immediately know the network has gone down because it is directly connected. So what router 1 will do, it will stop advertising about 1.1.1.1 network, because according to router 1, this network is removed from the routing table. Because it is directly connected, router 1 knows that the network is down, I need to throw it out, and it immediately throws it out. It has thrown it out. Every 30 seconds, the routes from the routing table will be advertised, but right now there is no 1111 in router 1's routing table. So router 1 will be advertising whatever the other networks it knows except this 1.1.1.1. But router 2 has learned already about 1.1.1.1 on this port. Let's say E0. It has already learned. But now it is waiting for the periodic update. Will router 2 receive any update now? No. It won't come because the network is no more and router 1 is not going to send the update anymore for 1111 network. So what router 2 does is, it is waiting. During the waiting time, router 2 will be advertising to router 1 about 1111 as if nothing went wrong. It advertises with hop count 2 to router 3. Every 30 seconds, router 2 is advertising the route to router 3 because router 2's routing table still holds the network 1.1.1.1. How long it will hold? It will hold for 180 seconds. During this 180 seconds, router 2 will be keep on advertising every 30 seconds about 1111 as 2 hop, as if there is nothing wrong. Router 2 won't advertise it this direction because of the split horizon. What a split horizon says, route learned from one port should not be advertised on the same port. So via E0, router 2 will not advertise back. Fine. Now what happens after 180 seconds? After 180 seconds, router 2 understands that this one hop is not true because I'm not getting any update. So what it decides is it decides as possibly down, PD, possibly down, possibly down. What is possibly down? Router 2 has decided that the network is no more. But router 2 has got some responsibility. What responsibility? It has to inform the downstream routers that the metric that I gave earlier is no more true. But before sending to router 3, it has to cross-check with the original sender, router 1. So it goes to router 1 and says, hey router 1, I waited 180 seconds. I found that network is 16 hop. Is that true? Is that true? 11111 is 16 hop. It is just sending this information to router 1. If it is not true, router 1 will say, hey, no, it is 1 hop. But because it is true, router 1 is quiet. This is what we call as Poisson reverse. It goes in the reverse direction and cross checks once.
Okay.
Sending with 16 hop to the downstream is what called as route poisoning. Sending with 16 hop so that router 3 will also remove this route by making it as possibly down in less than 60 seconds. So they all no need to wait for another 180 seconds. Router 2 has waited already. So router 2 sends the update with 16 hop so that router 3 need not to wait for 180 seconds. It receives the possibly down message as 16 hop. If there will be another downstream, it will send that same information to R4, and then in 60 seconds it will remove the route from the routing table. Going downstream is route poisoning. Going backward to the upstream is Poisson reverse. So we have seen split horizon, we have seen route poisoning, we have seen Poisson reverse. Any other question? Let's get into this EIGRP. Enhanced Interior Gateway Routing Protocol. This one is not a first version of Cisco's routing protocol. Before EIGRP, it was IGRP. And the administrative distance for IGRP was 100. Administrative distance of EIGRP is 90. We learned these things in the previous class. When we were seeing last week the introduction to routing protocol, we saw administrative distance is nothing but the preference value. EIGRP's administrative distance is 90. EIGRP's older version is what? IGRP. IGRP administrative distance is 100. But that IGRP is no more supported in, we won't see in most of the routers. Why? Because it is a class full protocol. IGRP is a class full protocol. EIGRP is a classless protocol. EIGRP is an advanced protocol compared to IGRP. IGRP is a distance vector protocol. EIGRP is also a distance vector protocol, but it is an advanced distance vector protocol. What advancement? One advancement is IGRP is class full, EIGRP is classless. Right? So EIGRP is a classless routing protocol. It's an advanced distance protocol. This protocol EIGRP is really different special from all other routing protocols. In what way? EIGRP can do load sharing, load balancing across unequal cost path. See, every protocol does load balancing if the path metric is same. EIGRP can do load sharing even if the path metric is not same. Unequal cost path, meaning paths metrics are not equal. Unequal cost path. Fine. So EIGRP is advanced distance vector protocol. EIGRP is a classless routing protocol. EIGRP supports unequal cost load balancing. EIGRP, instead of broadcast, it does unicast and multicast. No broadcast. EIGRP supports variable length subnet mask VLSM, so that you can have discontinuous network. What is discontinuous network? When I have 10.1.0.0/16, see 10.2, this is 10.1. Are they same network or different network? They are different network. This is 10.1, that is 10.2. But if you see in class full, then they are same network 10, this is also 10. This is class A, so /8. When it is classless, only then you can able to differentiate. See, that's what VLSM, supporting variable and subnet mask. This also supports discontinuous network. What it means, because it's a classless VLSM supporting protocol, when I have a network like 92.168.0.0/24, when this advertises, it will advertise as 10.2.0.0. When this advertises, it advertises 10.1.0.0. As a result, they learn each other. R1 learns about this network, R2 learns about this network, which is called discontinuous network. This is discontinuous. In the middle you got some other network now, so it is discontinuous. Even though it is discontinuous, you are seeing R1 able to learn R2 and vice versa, which is not possible if it is a classful protocol. Classful protocol advertises 10.0.0.0 here. This will also advertise 10.0.0. They don't learn each other because they are basically advertising the same network. So EIGRP supports VLSM and discontinuous subnet. See the fourth point. EIGRP, instead of sending complete routing table, it sends only those changes that happen. RIP, what it does is, it advertises the whole routing table. Even when there is no change, it will keep on advertising every 30 seconds the complete routing table, which is really bad because it consumes the bandwidth unnecessarily when there is no change. Not only that, not only it consumes the bandwidth, it also goes and disturbs every router process because they have to process this new update that is coming in. So sending complete routing table is not good. EIGRP, don't waste your bandwidth and process like that. It sends a triggered update only when there is a change, and it sends only the changes, not the entire routing table. Partial updates. EIGRP has got support for multiple network layer protocol. What is network layer? In OSI reference model, network layer is the third layer. EIGRP supports multiple network layer protocol. Multiple network layer protocol. What are the network layer protocols you know? IP. IPv6 is also IP only.
IPX.
IPX is another network layer protocol by Novel Network. Apple Talk is another network layer protocol. Honestly, I don't know what these are. I know only IP and IPv6. EIGRP says even if you are running IPX in your network, I'll do routing, I'll support routing, I'll distribute the routes. What routes? IPX routes. Anyway, those things are not necessary for us, not needed for us, but there is support for EIGRP. Sorry, there is support for IPX and Apple Talk. Who knows? A day will come, IP will vanish, and Apple Talk will come. Or IPX will come. Because it's not in our hand. Internet is not in our hand. There are chances that in one day to stop, to freeze the entire country, the IP may be pulled off. In those periods, EIGRP will grow bigger because EIGRP routing protocol is the only routing protocol that supports IPX and Apple Talk. I don't think OSPF supports. Maybe ISIs can be extended to make it support, but no other protocol, for my knowledge. And everything will start from zero level again in networking. Definitely there should be some reason behind why Cisco has designed EIGRP for multiple network layer protocol. When EIGRP was introduced, there was no IPX, there was no Apple Talk. Some people were telling lies when they were teaching like, hey, I have seen some IPX in my days, in that network, in this network. Those are all funny stories. I have gone around the world, I didn't see anywhere. So who knows, in future it may appear. That time EIGRP will be supporting the route distribution from one router to the other. Next, flexible network design. You see, inside the autonomous system of an EIGRP network, what is autonomous system? Autonomous system is one group with common policy. In networking, how do you define autonomous system? Group of networks and routers that are under single administration, technical administration. To identify EIGRP, to identify that group of devices under single technical administration, EIGRP uses a number. If I want 10 routers out of 100 router, I want only 10 routers to run EIGRP. Then how do you group the 10 router? With the help of a common number. Because that common number is same, the routers can form a group. We call it as autonomous system number. For autonomous system number, in EIGRP we have a number between 1 to 6553635. You may use any number in this range, any one number in this range, and put that number on every router, every adjacent router that you want to form a group and advertise the route between them. So you can decide how many routers will be in an autonomous system. There is no restriction, so it is flexible network design. Within an autonomous system, if you wish, you can have more than one autonomous. Within an office, if there is a need, you may have more than one autonomous group. The routes of one autonomous system group will not be advertised to other group, will not be learnt by other groups. So you can have flexible network design, you can have many groups if you want. Now EIGRP supports two type of summarization. One, auto summarization, which is also a global level summarization. Auto summarization is one type. Manual summarization is another type of summarization. Manual summarizations are done on the interface, on the port. Manual summarization are done on the port, on the interfaces. Auto summarization are done under the router mode, globally. That is what here it means, manual summarization at any point, meaning anywhere you like to summarize on any interface, you can do it. In a router you may have 2-3 interfaces, but you want to summarize only on one interface for one neighbor. That is possible because manual summarization option is available in EIGRP. Let me draw and explain you one more time what I said. Let's say I got three routers. Router 1, router 2, router 3. And I got some network here 1.1.1.1/32, 1.1.1.2/32. Now, if I will say no auto summary here, what will happen? Both the routers will get a detailed routes. Both the routers will get 1.1.1.1, 1.1.1.2, 1.1.1.3. Like this. But for some reason, you do not want to summarize on this direction. So what you can do is, you can go to this port and configure manual summarization. You can say You can say on this port the advertisement should be like 1.0.0.0/8. So router 3 will learn summary route, whereas router 2 will learn all the precise routes clearly. Yeah. So manual summarization at any point. Next, 100% loop-free classless routing. 100% loop-free classless routing. EIGRP uses an algorithm called diffusing update algorithm that will guarantee 100% loop-free classless routing. The dual algorithm not only picks the low-cost path, it also picks the path which will never have loop. How is that possible? Dual algorithm has got a condition called feasibility condition that makes the protocol to pick only the path that where there won't be any loop. More detail is coming on the third or fourth slide. Now configuring EIGRP on the WAN interface and on the LAN interface, both are same almost. So for those who are working on the LAN side, working on WAN side is not a big deal, it's easy. As I said earlier, load balancing can be done across multiple links even if you have unequal cost path. Okay, how many paths? Maximum of 4 paths including the primary path by default. But if you wish to have more than 4 paths for load sharing, that is also possible. Kindly ask me a question if you have any on this page. Alright, next page. See, every protocol except RIP, every other protocol maintains neighbor table. What about ISIs? ISIs also maintains neighbor table. Except RIP, every routing protocol will have a neighbor table. Why in RIP there is no neighbor table? Because RIP never discovers neighbor. RIP never discovers neighbor. Whereas EIGRP, OSPF, ISIS, BGP, they all form neighbor. EIGRP forms neighbor by sending hello packets every 5 seconds. So it is the hello packet that is sent between the routers helps to discover them. Not only that, it's the same hello packet that helps to maintain the neighbor. Maintain the neighbor. Hello packets helps to maintain the neighbor. As long as the hello comes, the neighbor will be in the neighbor list. If a hello is not coming for 15 seconds, then the neighbor will be removed from the neighbor table. So it is based on the hello packets, the neighbors are identified, maintained, and neighbors are removed. That is also based on the hello, absence of hello. Because hello is not coming for 15 seconds, the neighbor is going to be removed. Next is the Reliable Transport Protocol, RTP. RTP, Reliable Transport Protocol, RTP. RTP is a protocol that guarantees the delivery of EIGRP packets to the neighbor. Why? because EIGRP don't use TCP for guarantee. EIGRP is not layer 4 protocol or layer 7 protocol. EIGRP works in layer 3 IP. So there is need for an additional protocol to provide guarantee. This reliable transport protocol provides guaranteed delivery of EIGRP packets to all EIGRP neighbors. Next, as I said earlier, EIGRP has got an algorithm called diffusing update algorithm, DUAL, diffusing update algorithm. Diffusing update algorithm finite state machine. This is the one which is going to pick the best path, the low cost path. Also, the path will be a loop free path for every destination. As I was telling you earlier, EIGRP is designed with 3 packages. One package supports IP. If you enable another package, which is AppleTalk package, it will support AppleTalk. The IP version of EIGRP cannot support AppleTalk or Novel Network. So, they are independent of each other. Each protocol has got its own EIGRP module and operate independently of any of the other that may be running. Please ask me a question if you have any here in this speech. EIGRP has got 3 tables: neighbor table, topology table, and routing table. Neighbor table will have the established neighbor information. Established neighbor information. Topology table will have the information of the primary path, which is called successor route, and the backup path, which is called feasible successor route. Whereas the routing table will have only the primary route, which is also called as successor route. To understand the topology table much better about the successor route and feasible successor route, we need to understand this page very well. I want you to take some time, read this, understand this as much as possible, so that when I explain you after this break, you will get it faster. Read this page. This page is very important for those who want to say, I know EIGRP. I'll pass it here. You see, every protocol picks a route. And that route, based on the metric, it picks. EIGRP also has got 5 metrics, out of which 2 are considered. The metric of EIGRP is slowest link bandwidth plus sum of delay. Slowest link bandwidth plus sum of delay. Together we call it as composite metric. Bandwidth and delay together is called as composite metric. So, the low cost path is selected as the best path. Now, it also need to be a loop free path. How a loop free path is selected? See, for example, here you got router 1, router 2, router 3, router 4, router 5. So there's a network called 5.5.5.5 advertised. It's advertised. Now, if there is a loop, say for example, router 4 is advertising with a metric of some number I'm giving, for example 10. If there is a loop like this, R2 will not advertise 10. Instead, R2 will advertise 10 first time. It will advertise 10 first time. But when there is a loop, 10 plus, let's say here, 1 10, here another 10. So if there is a loop, 10 plus 10, 20, 20 plus 10 is 30. Again, when it comes here like this, 40. So it will advertise 40. If there is again loop, 50, 50 plus 10, 60. Again, 60 plus 10 is 70. It will advertise 70. So this is going to keep on increase if there is a loop. When there is a loop, the incrementation will happen for the same network. To avoid this loop path, there is a condition called feasibility condition. This is what the definition for the feasibility condition. The advertised distance of the feasible successor must be less than the feasible distance of the current successor route. What it means. Let's say we got two routes. Now router 1 is learning route about 4.4.4.4 from both router 2 and router 3. Let's say the metric here is 10 and 10 and 10. So according to router 2, what is the total distance? What is the total distance? 20. 10 plus 10, 20. According to router 3, same 20. 10 plus 10, 20. This total distance is what called as feasible distance, FD. Total distance. Now router 2 will advertise 4.4.4.4 to router 1 with a metric of 20. Router 3 will also advertise with a metric of 20. And what router 1 will do, it will learn this advertised distance from each router. What is the advertised distance? The metric that is given by the neighbor as an advertisement is the advertised distance. So according to router 1, it learns the same advertised distance from both R2 to R2 and R3. 20, 20. And let's say here again 10 and 10. So total distance from R1 to 4.4.4.4 via R2 is going to be what? 20 is the administrative distance plus the distance between R1 and R2 is 10. That is what called as feasible distance. Look at this. Cost from the local router is equal to advertised distance of the next router plus cost between the local router and the next router. Advertised distance is 20. Local router to next router is 10, which is 30. Same way, via router 3, advertised distance is 20 plus cost between the local router and the next router is 10, 30, which is called equal cost path. And this 30 will never increase, it will be stable. As a result, there is no loop, and path will be both the paths to reach 444 because the cost is equal. EIGRP supports unequal cost path. What does that mean? You see, let's say here you got 15. So now what is the FD value via router 2? Same 30. What is the FD value via router 3? 35. The path with the small FD, low FD, is called as low cost path. The low cost path will be elected as the successor route. So all the packets will go via the next hop, router 2 now. It won't go via router 3. That's the successor route. Successor route is nothing but the current path via which the packet will be forwarded. Current next hop to which the packets will be forwarded for destination. That is successor route. Successor route is nothing but elected route. Elected route is nothing but current route. There is no problem in understanding up to this level. But when we talk about feasible successor, people are confused. What is feasible successor? Successor means current route. What is feasible successor? Feasible successor is nothing but backup route. If the current route goes down, you will use this as the successor. In the topology table, you will find both successor route as well as feasible successor route. Whereas in the routing table, we will have only the successor route. In the routing table, we will have only the successor route. In the topology table, we will have both successor and feasible successor. So feasible successor is nothing but backup route. See, for a route to be backup, in order to select a backup route, EIGRP need to make sure there is no loop. How it is going to do that? It says the advertised distance of the backup route, the advertised distance of the feasible successor. What is the advertised distance of the feasible successor? This is what the path R3 is, the feasible successor path. What it is advertising? 20. Advertised distance of the feasible successor, which is 20, must be less than the FD value of the, FD is nothing but total distance of the current successor. What is the current successor? Current successor is via router 2. What is the total distance? 30. 30 is the FD. Is 30 or is AD, advertised distance of the alternate path, less than 30? Of course, yes. If only yes, this route via router 3 will be placed into the topology table. If not, EIGRP will not install the alternate path in the topology table. Question, please. Ask question. Ask me question.
This looks the way you have written right, sir. It is pretty self-explanatory. Would you be able to share this document?
Okay.
this PDF.
You want my writings also?
No, we would get that recording, but this the document looks good.
No problem. Fine.
Okay.
So the advertised distance of the alternate path, which is R3 path, must be less than the total distance via R2 path, which is the successor path. Why is this condition? To prevent loop. See, if there is loop only, the advertised distance will be keep on incrementing. If there is no loop, there won't be increment and it will be less than the successor value most of the time. But what if this is 30 here? Advertised distance will be now 30 plus 10, which is 40. Is 40 less than the successor route? No. So this route will not be seen in the routing table. It will not be seen in the topology table. So when the primary route goes down, R1 will not find the backup route. R1 will query for a backup route. R1 will query. If this primary route goes down, R1 will query R3 for the backup route. So there is a query if there is no backup route. Query will be sent to all the neighbor so that the neighbors may know the destination where to reach. Fine. So far what we have seen is how EIGRP dual algorithm selects a path, both primary and backup, both feasible successor and successor. Successor means primary, means elected current route. Feasible successor means backup route. Feasible successor will be available only when feasibility condition is met. What is the feasibility condition? Advertised distance of the backup path must be less than the total distance of the primary path. So that's how the table will have the table will have the successor route and the backup or the feasible successor route. For every destination, the topology table will maintain the successor route as well as the feasible successor route for each neighbor. Neighbor table will have all the neighbors and the address to reach them and the interface via which they can be reached. And routing table will have only the best routes, whereas topology table will have both best and backup. I want you to take a minute time, go through this, understand this. I'm going to ask you a question. This picture is what we have seen here. A portion of this page is picturized here. I'll give you a minute. Right, EIGRP sends 5 different type of packets. As we already learned, hello packets are sent every 5 seconds. This helps to establish neighbor. Not only that, this helps to maintain neighbor. Updates are sent whenever there is a change in the topology. When when update is sent, the receiver will send an acknowledgement for the update. When a router receives an update, it sends an acknowledgement to the one who sent it. That's the last packet type, acknowledgement. Queries are sent whenever a primary path has gone down and when there is no secondary path. Whenever there is a successor route gone down and when you don't have feasible successor, a query asking the neighbors for the lost route, for the route that is gone, the primary route that is gone, the primary path that is gone. We call it as query. And when a query is received, the router will send an acknowledgement saying, I received your query. And then followed by the response is called as reply to the query. When a reply is received, the receiver will send an acknowledgement again saying, I got your reply. So query and reply is only when there is no feasible successor. Otherwise you will not find query and reply. What about update? Update is sent whenever there is a topology change. Whenever there is a topology change, the update is sent to every neighbor. Sometime it will use multicast, sometime it will use unicast. You will see both. Initially it will start with multicast, then it will go to unicast. Where? When it sends an update. Most of the time hellos will use multicast address, but sometimes even the hellos will go with unicast along with the update. If you will sniff packet and see using packet tracer, you will see these things clearly. How often the hello packets are sent? 5 seconds. If a neighbor is not sending hello for 15 seconds, the neighbor is considered as dead and the routes given by the neighbor will be thrown out because the neighbor is now considered dead. So we can see here the hello packets are sent by both the routers. Initially, router A sends the hello packet. Router B learns it in the neighbor table. And router B sends an update as a multicast. And router A receives the update, sends an acknowledgement, and sends an update as a unicast because it's a well-known neighbor for both A and B now. So initially it will be using multicast for update, later it will be unicast. For update as well as for query and reply, there will be an acknowledgement sent. But for the hellos, there will not be any acknowledgement. EIGRP has got this 5 metrics. But these two will be always considered by default. The reason is the reliability and load is a variable one. They go up and down, up and down. So you cannot depend on something which is going up and down. You cannot depend on something which is going up and down. For example, if you are starting a business, you need to pay salaries and you need to provide for maintenance, and there's a big money that is needed every month. You need to give salary and maintenance. If the market is always up and down, when it is up you are happy, but when it is down, how will you pay salary? How will you pay rent? So one should not start business depending on the market. He should have his own ways to meet the needs. Only then he should start a business. EIGRP also wants to have a reliable metric components. That's why it goes with bandwidth and delay. They are reliable. Bandwidth and delay never changes for a wire. If you take a wire, if that wire supports 100 meg, that 100 meg is always supported. But the load on the wire will go up and down. When someone is downloading too much, the load goes higher. When someone finishes downloading, then load goes below, lower. When load is high, the reliability is going down. When load goes down, reliability goes higher. So those things are, reliability and load is variable. But bandwidth and delay value for each link is fixed value, constant value. So EIGRP depends on the constant components, not the variable one. MTU, though it is a constant one, EIGRP don't focus on MTU because MTU is another constant value. You already have two constant values to consider. That's enough. At the time this presentation was written, EIGRP was also there. But now no more EIGRP, as I said earlier. Both EIGRP and EIGRP uses the same metric components. But the number of bits for EIGRP is only 16. For EIGRP it is 24. For EIGRP is 8 less. So whenever you want to calculate the metric of EIGRP with EIGRP, you need to multiply by 256. If you are calculating EIGRP metric from EIGRP, then you need to divide by 256. There is another difference in the bits. EIGRP uses 32-bit, not 24. EIGRP uses 32-bit, EIGRP uses 24-bit. So 8-bit extra for EIGRP. That's why you need to multiply 256 with EIGRP metric in order to get EIGRP. Not important for us. So here one thing is important is EIGRP uses composite metric, both bandwidth and delay. These three are not considered. But if you wish to make EIGRP to consider these or any one of these, it is possible. We have a command called metric weight to enable these in EIGRP so that it can consider. The default is slowest link bandwidth plus sum of delay. You see, what is the metric of EIGRP? Slowest link bandwidth from sum of plus sum of delay. That's the metric of EIGRP. All the other things are not really needed, not necessary. Why? This is bandwidth, this is delay. All other things are 0. Anything multiplied by 0 is 0. So they are not going to be really making any difference. So the best metric definition for EIGRP is the slowest link bandwidth plus some. That's why they have given in red color. What is the metric of EIGRP? Slowest link bandwidth plus sum of delay. What does that mean? It means this. Look at this. Between A and D, there are two paths. Between A and D, there are two paths. You can go via B. You may also go via XYZ. If you go via B, what is the deal? Slowest link bandwidth. We saw just now it is bandwidth plus delay. It is not simply bandwidth, the slowest link bandwidth. Which is the slowest link here? This is the slowest link, 64 kilobits. So between A and D, if you are going via B, it will not see this T1. T1 is 1500 meg. Means 1.5 meg. 1.5 meg, not 1500. 1500 KB. 1500 kbps. It won't see this 1500 kbps. It will see only 64 kbps. Between A and D, if you are taking the path via B, what is the bandwidth that is considered? Not T1, the slowest link bandwidth plus sum of delay 2000, 2000, 2000, which is 6000. Whereas if you are going via XYZ to D, 256 is what's seen in everywhere. So that's the bandwidth is taken plus sum of delay 2000, 2000, 2000, 2000. Taking all this, and bandwidth will be 10,000 divided by bandwidth in kilobits, which we just now saw, 64 kilobits multiplied by 256. Likewise for delay in tens of microsecond, which is 8,000 or 6,000 into 256, and you add both of them. Don't need to worry about these things. You are not going to multiply, add all those things. This is how the calculation is happening. That's what we need to know.
Sir, one question in that slide.
Yes.
So, how A will know whether link between C and D is 64 kbps? It will just do calculation based on the AD value which B is sending, right?
Correct.
So
and B will depend on what C is sending. You know?
So at the end, the calculation happens only on the AD value sent by the neighbors, right?
Correct. Correct. Now, this is what I was telling you earlier. If you are running both IGRP and EIGRP in the same autonomous system, there is no need for redistribution between EIGRP to IGRP. You don't need to redistribute. You don't need to translate between them. Why? They both have the same autonomous system number. They both are from Cisco. They both are compatible. Only difference is this is classful, this is classless. Now another difference is the metric. As I said, 256 times more than IGRP is what EIGRP metric. So if you multiply 256 into the IGRP metric, which is 1000, you get the metric of EIGRP. Likewise, if you multiply 2000 with the 256, you get EIGRP metric. In IGRP it is 2000, in EIGRP it is 51,200. No. 5,12,000. 256 times bigger. The reason is the metrics are calculated using 24 bits in IGRP. The metrics are calculated in EIGRP using 32 bits. Not so important. This page is not so important. right? So in this page, in this chapter, we learned about the very good introduction to EIGRP, what it is, and how the best path is calculated, how the dual algorithm can guarantee a loop-free network, different packet types, the 5 different packet types: hello packet, update packet, query reply packet, then acknowledgement. Then we learned about the metric, the slowest link bandwidth, the sum of delay. The other metrics, like load, reliability, MTU, can be considered if it is needed, but not by default. By default, it is only the bandwidth and delay because they are constant. At last, we saw the compatibility between EIGRP and IGRP is very good because they both are the same proprietary protocol designed by using the same dual algorithm. The only difference is there are a few differences. The main differences are EIGRP is classless, IGRP is classful. EIGRP uses 32-bit for metric calculation, IGRP uses 24-bit. So if you will multiply 256 to IGRP metric, you will get EIGRP metric. Or the other side is, if you want IGRP metric from EIGRP metric, then you need to divide by 256. Right? So